So classless addressing. Another name is CIDR routing, that is classless interdomain routing. Solves the problem of classful address depletion. Variable length blocks are used that belongs to no class. CIDR notation is like this. So it is represented in this form. So three things are required. How many network addresses? First address and last address. Rules for creating a CIDR block. A CIDR block is created based on the following three rules. Rule number 1. All the IP addresses in a CIDR block must be contiguous one after another. Rule number 2. Size of the block or the total number of IP addresses contained in the block should be of a power of 2. So it can be 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4 and so on. Rule number 3. First IP address of the block must be divisible by the size of the block. So given a CIDR representation, find the range of the IP address. So first what we'll do 32, that is the total number of bits, minus 27 is given. So the answer is 5 bits. So to find the first address and the last address, that is the range of address, the last 5 bits we will write them as 000 for the first IP address, and the last 5 bits will be represented as 1111 for the last IP address. So 20.10.30 will remain as it is. 35 is 0010011. This is the representation for 35. Now instead of this, what we'll do, we'll write 001 1 2 3 4 5 1 2 3 4 5. If this you put in the calci, you get the decimal equivalent as 32. So we say 20.10.30.32, and the last IP address will be 001 1 2 3 4 5. If you put this in the calculator, we get the decimal equivalent of the binary number as 63. So 20.10.30.63 is the range. For classless, how address mask is used to know the first and the last address. So number of addresses not mask plus 1, first address IP address and mask, and last address is IP address or not mask. Broadcast address, by putting the host bit as 1 and retaining the network bits as in IP address, is the broadcast address. So consider a block of IP address ranging from 100.1.2.32 to 100.1.2.47. Is it a CIDR block? If yes, give the CIDR representation. So rule number 1 is, according to rule 1, all IP addresses must be contiguous. Clearly we can see that all IP addresses are contiguous. So rule number 1 is satisfied. For rule number 2, we have to see it is a power of 2. So for that we will do 47 minus 32. This is 47 minus 32 plus 1, that is 16. 16 can be written as 2 raised to 4. So it is clearly a power of 2. So rule number 2 is satisfied. For rule number 3, we saw that the first IP address must be divisible by the size of the block. So first IP address was 100.1.2.32, must be divisible by 2 raised to 4. So clearly 32 will be divisible by 2 raised to 4 since its 4 least significant bits are 0. So rule number 3 is also satisfied. Since all rules are satisfied, therefore the given block is a CIDR block. Subnetting, we have a big single network having IP addresses 200.1.2.0/24. We want to do subnetting and divide it into 2 subnets. So this is what we have done. We have divided into 2 subnets. For creating two subnets, we represent their sub IDs. We require 1 bit. So we borrow 1 bit from the host ID part. After borrowing 1 bit, host ID part remains with only 7 bits. So when you borrow 1 bit instead of 8, it will become now 7 bits. So borrowed bit equal to 0, then it represents the first subnet. If borrowed bit equal to 1, then it represents the second subnet. So given an IP address, find the network IP address. So you get 1.0.0.0 direct broadcast address. Keep the net ID bit as it is and host ID bits will be replaced by all ones. So you get 255.255.255. Limited broadcast address will be 255.255.255.255. This belongs to class B. So network address will be 130.1.0.0. Direct broadcast address will be net ID kept as it is. Host ID becomes all ones. So 255.255 and limited broadcast address. So if class B on the internet has a subnet mask of this, what is the maximum number of hosts? 11 bits for the host. So 2 raised to 11, that is 2048 minus 2, 2046. So this is IP address allocation, and ISP is granted a block of address starting with 190.100.0.0/16. The ISP needs to distribute these addresses to 3 groups of customers. First group has 64 customers, each needs 256 address. Second has 128 customers, each needs 128 addresses. And the third group has 128 customer, each needs 64 addresses. So first is each customer needs 256 address. 8 bits are needed to define each host. Prefix length is 32 minus 8, that is 24. So your addresses will be 190.100.0.0.24, 255, then 1.255, 2.2.255. That will come till 63.0. So total will be 64 into 256. That is the 64 customers into 256 address. So 16,384 will be the total. Each customer needs 228 addresses. 7 bits are needed. Prefix length is 25. So addresses are 190.100.64.0 till 64.127. Then 128 to 255. Then 127.128 to 127.255.